Welcome to the world of science and technology. Is it possible to know the electronic structures of materials? Or is it possible to peer into the quantum world? So this is the question. And answer to this question is yes, this is possible. By the help of one special technology is there known as STS, means Scanning Tunneling Spectroscopy. Last day one video was posted on the same channel. The name of the technology was STM, that is Scanning Tunneling Microscopy. And here today we are talking about STS, that is Scanning Tunneling Spectroscopy. So from microscopy to spectroscopy. So what is the use of STM? If we talk about first STM, then what is the use? To know the topological surface structure or the atomic structure. Images of the atomic structure is taken. Images of the atomic structures are taken by the help of STM. But to know the electronic structure of materials, that means to know the density of states of a material, this is required. This means what? STS is required. That is a Scanning Tunneling Spectroscopy. So in both the technologies, one principle of quantum mechanics is used, and the name of that quantum principle is quantum tunneling. And the same device can be used for the purpose of STS. So in case of STM, what is actually done? In case of STM, you know that there is a sharp metal tip, and that metal tip hovers over a surface, means sample surface, of which you are interested to take the images of the atoms. Okay. So anyway, here also same thing. There is a sharp metal tip, and which is able to hover over a surface. But here it does not move over the surface. It remains at a fixed location. So in case of STM, what is done? A voltage is applied, and there is a current is developed. That is that current is known as tunneling current, and that tunneling current is measured. And that way, the reconstruction of the required images is possible. But in case of STS, the voltage does not remain fixed. In case of STM, the voltage remains fixed at a constant value. But in case of STS, the voltage does not remain fixed. The sharp metal tip is placed at a fixed location over the sample surface. And then the voltage is applied, and accordingly the current can be measured. Then the voltage is changed. So due to the change in voltage, accordingly there will be a change in current, and that current is again measured. So at a fixed location for different voltages, different currents are there, and all those things are measured. So that way, for a fixed location, you are getting a set of data, and by using that set of data, you can plot the graph I versus V, that is current versus voltage. And from there, you can easily calculate dIdV, rate of change of current with respect to the voltage, dIdV. And by the calculation of dIdV, you are able to know the extraction of the electronic structure or extraction of the electronic data is possible by using that dIdV, or by using that graph I versus V, that is current versus voltage. So what is the difference between STM and STS? While you are performing the experiment, in that case the difference is, in case of STM the voltage remains constant, but in case of STS the voltage does not remain constant. It varies, and accordingly there is a change in current, means tunneling current. A set of data is required, okay, and therefore you are able to plot the IV curve or the IV graph. Okay, and from that IV curve or IV graph you are able to calculate DI/dV, and that way the electronic data can be extracted. So this is the difference. What is the use of STS? Different fields are there where it can be used. It is used actually in case of supercomputing. This is used in case of nanotechnology. This is used in case of superconductors, in case of semiconductors, transistors. So wherever there is a requirement to know the electronic structure, such as band gaps are there, energy gaps are there, so different terms are there. Okay, then density of states, DOS, in short this is known as DOS, density of states. So to know all these things means to know the quantum world or intricate details of the quantum world. This technology is used, STS, and this technology is revolutionizing many other technologies, because just by knowing the quantum world in detail, we are able to develop many technologies. That means this technology, STS, is very important. It plays a crucial role in the advanced technologies, because nanotechnology, superconductors, then quantum computing systems, all these things are advanced technologies. In all these fields, especially in the field of material science, you'll find a great use of this technology, STS. So, the device remains the same, and while doing the experiment or while doing the investigation, the procedure changes somewhat. Okay, so there is a requirement of DI/dV, this data. Then only you can know the required electronic data. Means to know the electronic structure of materials, this data is required. Anyway, so this was all about the topic STS. Okay, Scanning Tunneling Microscopy. So here also the same principle, that is quantum tunneling effect, is used. Quantum tunneling of electrons, okay, is happening here in this case also. Anyway, so this was all about today's topic, and this is the end of this video. Thank you for watching this video.